A tree that grows 20 feet in a single year should not exist. In 2004, a forestry study published by the USDA Forest Service measured Paulownia tomentosa biomass yields at over 12 tons of dry wood per hectare annually, 3 to 5 times the yield of commercial pine plantations. Chinese imperial records dating to the Zhou dynasty, roughly 700 BCE, document Paulownia as sacred, planted at the birth of daughters, harvested at marriage, shaped into instruments presented only to royalty. Its wood is lighter than balsa but stronger than pine, resists warping across humidity extremes, and contains natural oils that repel moisture for decades. Yet in 1999, it was officially listed as invasive across 12 American states. Not because it poisoned soil, not because it killed wildlife. The system rarely bans what it cannot profit from. This tree was not erased from American forestry because it failed. And the reason buried in industry reports will reframe everything you think you know about invasive species. Paulownia carries the weight of empires in its grain. In feudal Japan, the Paulownia crest, the kiri, adorned the official seal of the prime minister, a symbol reserved for the most powerful office in the nation. The tree was considered so precious that families buried instruments made from its wood alongside the deceased, ensuring beauty survived death. Tang dynasty craftsmen selected only aged Paulownia trunks to construct the gukin, a 7-stringed zither whose resonance required wood so acoustically alive it seemed to breathe. European botanists first encountered it in the early 1800s. Anna Paulowna of the Netherlands, daughter of Tsar Paul I, gave the tree her name after specimens reached Western collections. Victorian horticulturalists described its flowering as violet smoke rising from bare wood, blossoms appearing before a single leaf unfurled. The fragrance carried hundreds of meters on spring wind. No tree in temperate botany blooms with such theatrical abandon. History recognized what modern agriculture quietly chose to ignore. Paulownia defies the logic of conventional timber biology. A standard hardwood requires 40 to 60 years to reach harvest maturity. Paulownia reaches commercial harvest in 7 to 10 years. After cutting, it does not require replanting. The root system regenerates an entirely new trunk from the stump, a process called coppicing, producing straight-grained timber again within 5 years. One planting can theoretically yield multiple harvests across a century. The root system descends 6 meters or more into subsoil, unlocking minerals unavailable to shallow-rooted crops. In a single growing season, a mature specimen absorbs roughly 10 times more carbon dioxide than an equivalent stand of oak. NASA-affiliated environmental researchers have cited Paulownia as among the highest efficiency carbon sequestration trees known to temperate horticulture. Its canopy cools the ground by 12 degrees Celsius on peak summer days, creating a microclimate that protects understory plants. The biology alone makes it one of the most extraordinary trees ever studied. The industry looked at those numbers, then looked away. Paulownia wood occupies a category that conventional timber markets have no framework to describe. Its density registers at 275 kilograms per cubic meter, the lightest hardwood documented in commercial forestry. Yet its strength-to-weight ratio surpasses oak, cherry, and ash in multiple compression tests. Japanese shipbuilders historically used Paulownia for sandal making and storage chest construction. The wood so dimensionally stable that kimonos stored inside for decades emerged without moisture damage. It does not split under nail and screw pressure. It does not absorb flame rapidly. Its ignition temperature is measurably higher than most softwoods used in construction. Furniture makers in Shandong province have produced Paulownia bedroom sets documented to remain warp-free across 80 years of use. Modern acoustic guitar manufacturers in Spain and South Korea have begun replacing Sitka spruce soundboards with Paulownia, citing superior resonance at reduced weight. The wood sings before it is shaped. No synthetic material replicates what a single Paulownia trunk produces in under a decade. In 1999, the United States federal and state agencies began classifying Paulownia tomentosa as an invasive species. The classification spread rapidly. 12 states, then 18, restricting planting, sale, and propagation. The official rationale cited seed dispersal. A single tree produces up to 20 million seeds annually, lightweight enough to drift on wind for kilometers. Conservation agencies pointed to its colonization of disturbed roadsides and forest edges as ecological disruption. These facts are accurate. They are also incomplete. Paulownia does not establish in healthy, closed canopy forest. Peer-reviewed ecological studies confirm it colonizes only disturbed land, roadsides, abandoned fields, construction sites, where native vegetation has already been destroyed. It does not outcompete undisturbed ecosystems, it repairs broken ones. Meanwhile, the timber industry lobbied for restrictions without funding research into managed plantation cultivation, a critical omission. Managed monoculture pine produces far greater ecological disruption than controlled Paulownia groves. The distinction between managed cultivation and wild spread was never made official. The label stuck. The plantations did not. While American regulators debated invasiveness, agroforesters across 3 continents built economies around Paulownia. China currently maintains over 3 million hectares of managed Paulownia plantations, producing timber, biomass fuel, and erosion control infrastructure simultaneously. Spain, particularly Galicia, emerged in the early 2000s as Europe's primary experimental Paulownia cultivation zone, with yield trials producing 15 cubic meters of timber per hectare annually. Brazilian researchers began intercropping Paulownia with soybeans and maize, demonstrating that the canopy shading reduces water evaporation by 30% during dry season without reducing grain yields beneath. Korean environmental agencies planted Paulownia across post-industrial contaminated zones. The deep root system extracted heavy metals from degraded soil, a process known as phytoremediation, demonstrating ecological utility far beyond timber. India's national agroforestry policy formally recognized Paulownia in 2014 as a priority tree for smallholder land restoration programs. The global scientific consensus was forming. America remained officially restricted. The global record contradicts every assumption the invasive label was built upon. Paulownia carries survival mechanisms that seem borrowed from a different evolutionary era. After wildfire destroys the above-ground structure entirely, the root crown, protected deep beneath the soil, regenerates new shoots within weeks. Historical accounts from rural Japan document Paulownia groves recovering visibly within a single growing season after village fires consumed surrounding timber. Its bark contains a compound called paulownin, studied for antifungal properties in laboratory settings, which may contribute to its resistance to pathogen infiltration in field conditions. Flood tolerance is equally remarkable. Root systems survive submersion that kills commercial softwoods within days. Drought response is counterintuitive. Rather than dying, Paulownia enters partial dormancy, shedding leaves to conserve moisture and resuming growth when rain returns. No irrigation infrastructure, no chemical intervention, no replanting after catastrophe. The tree manages its own survival across conditions that bankrupt conventional plantation forestry. In an era of escalating climate volatility, this capacity is not a botanical curiosity. It is a blueprint. Paulownia is the fastest-growing hardwood on the planet, the lightest timber with the strength of oak, and a carbon sink more efficient than a mature forest. It regenerates after harvest, without replanting, repairs degraded soil, and survives fire, flood, and drought without human intervention. It was sacred to Chinese emperors, beloved by Japanese craftsmen, studied by NASA-affiliated researchers, and adopted by governments across Asia, Europe, and South America. And in the country that calls itself the world's most innovative agricultural economy, it is banned in 18 states. The invasive label is not wrong. It is simply incomplete. A legal framework designed for the wild tree, never applied to the managed grove. Every legitimate ecological concern about Paulownia has a known horticultural solution: sterile hybrid varieties, managed plantation boundaries, root barrier systems. The research exists, the technology exists, the political will does not. Somewhere between the imperial garden and the regulatory filing, a tree capable of rebuilding broken land became a liability on paper. The soil does not read policy documents. It simply grows what survives.